All right, good morning, everyone, and welcome to the last 3 pages of the notes. And we're going to continue solving systems of differential equations using eigenvalues and eigenvectors. And so today we're going to talk about what if, instead of case one, where we were able to find two eigenvectors for an eigenvalue, now we're going to have the case where there's only one eigenvector for an eigenvalue that repeats more than once. So like multiplicity 2 or multiplicity 3. So suppose that lambda sub 1 is an eigenvalue of multiplicity 2, and there's only one eigenvector associated with this value. A second solution can be found of the form x sub 2 equals kt e to the lambda sub 1t plus pe to the lambda sub 1t, where k is going to be an eigenvector, and then p is going to be an additional eigenvector with this eigenvalue. So how do we find p? Well, to see this, we substitute in x sub 2 into the system. And when we substitute in x sub 2 into x prime equals ax, what we're going to get when we do the derivatives and everything, we're going to get our initial eigenvector times t plus our new eigenvector times e to the lambda sub 1t. Okay, now to get this new eigenvector, the eigenvector of p, let me fix this because that print these should be on the inside. All right, we're going to, will give us our first eigenvector, and then this will give us our second eigenvector, where everything's, it looks the exact same. All right, you have a minus lambda, a minus the eigenvalue times the identity matrix, and then times k. This is how we have been solving our eigenvectors. Well, now we're going to do it, but we're going to have a new eigenvector, which we're going to call p, and we're going to set that equal to our eigenvector of k. And so that's the only thing new. We'll solve that, and we found our second eigenvector, and we're finished. So let's look at an example. Example 6, find the general solution of the given system. So we have a differential equation, negative 6x plus 5y, and the differential equation, negative 5x plus 4y, one with respect to x and the other one with, well, both with respect to t, but one independent variable of x or dependent variable x and dependent variable y. So again, I just write the coefficient matrix, and then I do the determinant. So nothing's new. We go ahead and find the determinant. When we do that, we get lambda squared plus 2 lambda minus 24 minus negative 25, because 5 times negative 5 is negative 25. We do that, we're ending up with lambda squared plus 2 lambda, it looks like an h, plus 1. And then we can factor that to lambda plus 1 squared. So we have a lambda, or an eigenvalue, of multiplicity 1, of 1 and multiplicity 2, so it repeats twice. So we're going to go ahead and substitute in lambda. All right, so this first step is where we're doing, again, a minus lambda I, and then k, and that's equal to the 0 vector. All right, so we substitute in, and we get negative 5 k sub 1 plus 5 k sub 2 equals 0, and then negative 5 k sub 1 plus 5 k sub 2 equals 0. Notice those are the exact same, so k sub 1 is going to equal k sub 2, and so we can choose k sub 1 is equal to 1, k sub 2 is equal to 1, all right? But, they're always going to have to equal each other, so that's why it's the same case, because they're always going to be the same. There's not going to be a case where k sub 1 is 7 and k sub 2 is 4, all right? Because they're always going to equal each other, so this eigenvalue only has one solution, and that's when k1 has to be k2. So making our lives easy, we're going to say k sub 1 and k sub 2 are just 1, 1. So we found our first eigenvector. So there's our eigenvector, and we can call that, technically we can call that cap k sub 1, right? I don't like saying that because my k's don't look, you can't really tell the difference between an uppercase k and a lowercase k, but that's an uppercase k. So that's the first eigenvector. All right, so, there's my, whoa, it's not a highlighter. There's my first solution, all right? Now, we got to do the second solution. Well, how can I do the second solution? Well, the second solution, just trying to erase until I get rid of that. Good. Oh. Just keep erasing until I get rid of that highlighter. All right, so there's our case of 1. All right, now to find the second one, we're going to do the same process, but instead of incorporating k, we're going to incorporate p. So notice all these k sub 1s, k sub 2s are now p sub 1s. And that should be p sub 2, not k sub 2. So let me fix that real fast. So p sub 2 and p sub 2. All right. So now that we know this, all right, the only thing that's really going to be different is we're just replacing all of our k's with p's, but the solution, instead of equaling 0, we're going to be equaling k. What is k? K is 1, 1, so it's going to equal 1, 1. And then we're going to solve the system this way. All right, once again, we get negative 5p sub 1 plus 5p sub 2 is equal to 1. So, in order to do this, what we can say is, well, if k sub 1 is equal to 0, then we can say, well, then k sub 2 has to equal 1/5. All right, now we could have solved it this way, or I should say p sub 1 and p sub 2. P sub 1 and p sub 2. Or we could say, okay, p sub 2 is 0, then p sub 1 would be negative 1/5. So you could have 0, 1/5, or you could have negative 1/5, 0. Again, I like to do it without negatives, so that's why I just chose 0, 1/5. So you could use either one. All right. Now that we found our eigenvector p, so this is p sub 1, this is k sub 1. There's only one eigenvector for k and one eigenvector for p. Now we're going to go ahead and plug it into our formula. So what's the second solution? Again, this is the second solution. That's what's above. We have k times t e to the lambda sub 1t. There's our t, there's our k, and there, lambda's negative 1, so negative t. And then we have p e to the lambda sub 1t. Well, that's going to be our p value right there. So p e to the negative lambda t. And then because that's x sub 2, we have the c sub 2 in front of it. So, and again, initially we would say x equals c sub 1, x sub 1 plus c sub 2, x sub 2. So we have that c sub 2 out on the outside. All right, that's it for that video. Hopefully you understand now how to solve for the second solution, given a repeated eigenvalue.